Today we are going to look at percentage yield calculations. It's actually a fairly simple calculation, but it can be combined with some of the trickier equations and calculations that we have already looked at. It's important to note that for percentage yield calculations, an experiment must have been performed. A lot of the trickier calculations we've looked at are all theory and maths based, whereas for this calculation, an experiment must have been done. To work out the percentage yield, you'll need two other yields. You'll need an experimental yield and you'll need a theoretical yield. As a reminder, a yield is an amount of product made. So in this reaction, our products are carbon dioxide and water. The yield would be how much of one of those we made. The experimental yield will be the amount made when you actually perform the experiment. A theoretical yield will be what you might expect to make when you use the maths. Let's put that into practice. Let's look at this easier question first of all. In an experiment, I expect 80 grams, but only make 20 grams. What's the percentage yield? Going back to this equation, the experimental yield, what I actually made, was 20 grams. What I expected to make, the theoretical yield based on the maths, was 80 grams. So according to this equation, experimental over theoretical is 20 grams over 80 grams times by 100 to make it a percentage. That gives me the answer of 25%. That shows us that as we expected to make 80 grams, we only made a quarter of our expected. We only made 20 grams, which is 25%. Now let's combine it with a slightly harder equation, a reacting mass calculation, in this example up here. I start with 8 grams of methane and I make 14 grams of water. What is the percentage yield? This is what I start with, 8 grams of methane. I make 14 grams of water. That is my experimental yield. That's what I actually obtained when I conducted the experiment. Now I need to use the 8 grams of methane to work out my theoretical yield. I have my experimental, I need to work out my theoretical using a reacting mass calculation. I start with my 8 grams. As we've done before, the molar mass of methane is 16 grams per mole. 1 carbon, 4 hydrogens, 16 grams. Moles is mass over MR, that's 8 divided by 16, which gives me 0.5 moles. The ratio is always looking at the balancing of the equation. I have 1 molecule of methane for 2 molecules of water, 1 to 2. 1 mole of methane would give me 2 moles of water. So the ratio is 1 to 2 there. I don't have 1 mole of methane. In 8 grams, I only have half a mole. So therefore, the ratio 1 to 2 would be half to 1. I times the moles of methane by 2 to get the moles of water. Half a mole times 2 gives me 1 mole of water. As in all the calculations, I then need to times moles by MR, which is of water, 1 oxygen and 2 hydrogens. 16 add 2 is 18 grams per mole. 1 mole times the molar mass gives me 18 grams of water. There's the reacting mass calculation. That is now my theoretical yield. I therefore have both the experimental and the theoretical yield. 14 grams was what I obtained when I actually did the experiment. 18 grams was what I expected to make when I did my reacting mass calculation. So now I put experimental, 14 grams, over theoretical, what I expected to make, 18 grams, and I times that by 100, which gives me the answer 77.7 recurring percent, or if I round it up, 78%. And that would be my answer there.